AB Calculus Note Card 15, Horizontal Tangent Lines. This is the 15th lesson in the series inspired by Stacy McMullen, formerly of the Towson School District, who developed this note card system that we use. Horizontal tangent lines. This is an extension of Note Card 13, which is just tangent lines. And you're going to see similarities here. To find the point where f of x has a horizontal tangent line, find f prime of x and set that derivative, or f prime of x, equal to 0, then solve for x. Then substitute that value of x into the original function to find the y value of the point of tangency. And when you have that y value, then that will be the x value that is consistent with that. And to actually find what that horizontal tangent line is, it's going to be a y equals equation. Okay? Let's go on and work a few problems here. For problems 1 and 2, find the point or points, if any, where the function has any horizontal tangent lines. And so following what's in the note card, we're going to take our first derivative of this function, f prime of x, which is going to be, using the power rule, 3x squared plus, we have 2 times 2, which is 4x, and we're going to have minus 15. And that's going to be our derivative there. Just a factor. We don't see any points in common. We're going to try to set this equal to 0. And I'm going to factor using that bottoms up or x method. We're going to have AC go up here and B down here. And A is equal to 3. B is equal to 4. C is equal to negative 15. So AC is going to be negative 15 times 3, which is going to be negative 45. And B is 4. So two numbers that multiply together equal negative 49, but add together equal 4. Well, I think 9 and 5 would work. So we have 9 and 5. And to get 4, which one has to be negative? Well, 9 has to be negative. So we add those together. Yeah, and we're going to divide by A now, which is 3, and simplify. So 9 over 3 equals 3. And then we have negative 5/3. So we have x plus 3 times quantity x minus 5/3. And using our bottoms up method, we take this 3 and bottoms it up here. So we're going to have quantity x plus 3 times quantity 3x minus 5. So I'll put this over here, x plus 3 times quantity 3x minus 5. And the point, or points of any. And we can just go ahead and quickly put this back together, see if we get plus 4x. Yeah, we get 9x here, and then minus 5x. Yeah, this all looks good. Yeah, all checks out. So using our zero factor property, we have horizontal tangent lines where x is equal to negative 3, and also where, let's see, x is equal to, 0, so 5/3. And so it says find points, if any. So our point is going to be, this will have to work out. Okay, points, so I have 2 points. We're going to have negative 3, comma, I'm just going to call it f of negative 3. Okay, I'm being a little lazy. That's going to, so if we plug negative 3 in for this as we get, and we're also going to have 5/3 comma, f of 5/3. And yeah, we plugged in 5/3 here to this original function, we would get that point. So those are our 2 points. Next, problem 2, g of t equals 2 over t to the 3rd power. So doing a calculus-friendly rewrite, we would say g of t is equal to 2 t to the negative 3rd power. And then g prime of t is equal to negative 3 times 2, or negative 6. And we're going to have t to the negative 4 power, which equals negative 6 over t to the 4th power. So if we set, I'm just going to work to the right here. If we replace g prime of t with 0 equal to negative 6 over t to the 4th power, I hope you can see that there is no value that we could make t be where this expression on the right side is going to be equal to 0. So we will say, since there is no solution for t horizontal tangent line does not exist. DNE. Okay, next, last one we'll look at is problem 3, a free response problem. Let h be a function defined for all x not equal 0, and the derivative of h is given by h prime of x equals x squared minus 2 over x for all x not equal 0. Find all values of x for which the graph of h has a horizontal tangent. So we're going to take this h prime of x and set it according to our instructions equal to 0. So we say 0 equals x squared minus 2 over x. And so we know that this is going to be a true statement when our numerator is worth 0. So if we say 0 is equal to x squared minus 2, we can actually factor this using the difference of squares. So here's our difference of squares. The square root of x squared is x, and then we have plus minus the square root of 2. So we have x plus square root of 2 times quantity x minus square root of 2. And so solving this equation, we're going to have x is equal to negative square root of 2, and also x is equal to square root of 2. It says find all values of x. So these are the values of x. So that is problem number 3 worked out. I hope this was helpful to you. Good luck, and thanks for viewing.